welcome back to AI Next Generation channel. So in the previous video we already have done about the activation function, how deep learning, what are introduction to the deep learning, different layer, input layer, output layer, hidden layer, their function. Okay, so if you have not watched, please go through it first because that is the really basic thing before starting this particular video. Okay, so in today our topic is how neural network works. Okay, so main thing is how neural network works. In the basics term I will explain you, because whenever you are just directly going through the coding part, you are just writing the code. Okay, so you don't have to write the directly the code. So you have to start from the basic. So the thing is that we have to just consider today about the how neural network works. So already I have just explained you about the input layers, the hidden layer and the output layer. So during input layer, hidden layer and the output layer. So in the input layer you will have the number of features. Okay, and in the input layers already we can just go through and watch that particular video. And in hidden layer everything that's a preceptron, that a preceptron basically call as whenever you have only, whenever you don't have any hidden layer you can just take. Okay, you have only the input layer and you have only the output layer. So in that case you are just calling that as a preceptron. That's it, because you are just calculating w1 x1 plus w2 x2 w3 x3 and so on. Okay, and you are just doing the summation. Then after you are just applying the activation function and you are getting this required output. So this is the basics in term we will explain you, because the main focus for you will be to know what are the how the neural network works and how the weights are updated during the back propagation. So in the input layer you will have w1 w2 so on and wn, and in the that is real that is your weights, and this particular line is a synopsis which hold the weights of that particular x1, and for the x2 it hold the weight as w2 and so on wn. Okay, so preceptron, now you will what you will just what will be the output, it will be x1 into w1 plus x2 into w2 plus x3 into w3 and so on. Okay, and this is how then after you will just apply the top of that activation function. Okay, you can just apply sigmoid activation function. So what you will get some output, then after you will compare with the actual. So we will just go through it from starting. Already I have just discussed the basic term. How does neural network learn? That is the first one will be there. Okay, so the power of neural network or deep learning, already you know that whenever it was case of the machine learning, you have to feed it like teacher forcing it was there. You have to say this particular features belong to this level, this particular feature or this particular row belong to this level. Okay, so but during the deep learning you don't have to go and say to that particular you have to follow this path. So during the deep learning what you are just doing, you are just directly updating that you are just giving directly the path. Okay, suppose you are just building a model that is able to classify between a cat and dog. So what you are just saying, you are just directly giving the path, you are just building the model, and you are just saying during the training time the deep learning is saying now I can handle everything. During the training time they will learn from themselves what you have just given the model, how many complex model you have just created at that. During the training time it will just train on that particular model, the data set will be trained, and from that particular data set they will just find some pattern to able to recognize between a cat and dog. This will be the basic follow step it will be goes. So this was the basic about how neural networks take the data set. Then after you will jump to that before it is also you have to just know about the preceptor was way invented in 1957 by Frank. So basically already I've discussed this thing in the one first video that deep learning was involved during the 90s only, but you don't have any resource to implement that. To implement that nowadays, like GPU and every computational power, the raise of everything was nowadays. So everything like GPU, you have now GPU, you have even TPU, even you have the high processor i7 i9. So they by developing this kind of things, so that particular computer can hold a highly computational power easily. So that is the power of deep learning. Means deep learning means you have to take something during the training time, you have to give some model that will be really heavy model. So even I3 can handle, but it will not handle like 20 or 30 or 50,000 of data set. So whenever this way we will I will just guide you in the separate next video. So what particular laptop you should buy for particular deep learning, to implement deep learning during the learning phase. Okay. So yeah, this was the basic idea about the this second slide. So during the third slide, what it is I am just mentioning, you are just calculating whenever you have just applied the activation function during the output. Okay, so output you will, y hat is basically the prediction, what model has been predicted, but now you will match with the actual. Now you will match with the actual, because what model has been predicted and what actual it is, the difference between them will be your loss. Okay, so why you are just calculating loss? Because with the help of this only you are able to see whether your model is performing good or not. Okay, so you can just look it here. The blue line represent this is your prediction, and the y is the your actual. So this is the loss basically. You can just see easily. So loss already I've just mentioned here, mean square loss. Okay, this is the basic mean square loss, because whenever you will do the coding part, then there you will use binary cross entropy, categorical cross entropy. We will discuss this loss everything in the next video. Okay, so here cost function you are just calculating y, you have the y 1 by 2 square of y minus y prediction minus y actual. Okay, so what model has been predicted and why what actual it was, it is the difference between the square root of that. Okay, this is what mean square error, mean absolute error, root mean square error, and even binary cross entropy, categorical cross entropy. We will discuss this thing in this next video. Okay, that is also the really important thing, but here you have to understand only the how neural network works. Okay, so you are just calculating now loss, but something you have to minimize the cost function. What you will do now, for that case you will do back propagation. So back propagation is really important things in the deep learning, because without back propagation your model will be like useless model, you can just say. Because whenever your model will can't update the weights, then what you will say, that particular model is a static model. But here what, during the forward propagation what you are doing, you are just you are just calculating this wi(xi) basically means w1 x1 plus w2 x2 and so on. Okay, now you are just applying on the top of that activation function, like sigmoid activation function you have applied, and you will get in something in the probability, or anything you are just get, you will get in the probability form, or any whenever you have any regression technique or house price prediction you want to do, then you can just applying any activation function. Then after you will get some output. Now you will just compare with that particular actual value, from actual value, and this is your prediction value. So now the difference between them will be your loss. But what, to minimize the loss you will use, what you will use, you have to adjust the weight. For that you are using, you have to go for the back propagation. So gradient descent, that also we will just look at in the depth of the gradient descent. But here just understand the basic concept of the gradient descent is that basically gradient descent where you will able to update the weights. Gradient descent is the most important things in the deep learning, where you want to minimize the cost function. For that we are using gradient descent, is basically it is updating the weights, and it's by gradient of that particular formula means derivative of loss with particular weight. Okay, so you are just adjusting the weight. So on the basic of weight adjustment you are seeing whether the your loss has been decreased or not. Okay, so we will go through again in the depth of the gradient descent when we will learn about the gradient descent. So here you have to just understand, to minimize the loss we are using gradient descent. On gradient descent what it is doing, it is just updating the weight, means it will give the higher priority to that particular feature. The most important feature will give the most weight. Okay, the more weight it will give to the most important feature. That's why weight update is going through on the backward propagation. So during the forward propagation you will get some output, and during the backward propagation you will update the weight. It goes on how many epochs you are taking. Epochs is directly that forward propagation you are doing, and the backward propagation means of epoch, one epoch equal to forward propagation plus backward propagation. Okay, so during the forward propagation you are just your model will predict some output, and during the backward propagation your model will update that particular, okay, weights. So this is the really important topic of this particular your weight adjustment technique, how it is going on. So this was the really basic. Even I have just taken the example, I think I have just taken the 4 rows example. Here you can just see you have total 4 rows. The really basic example you have to just understand. So this is the basic index you don't want. So study hours, sleep hour, and cues, this is the basically your features, and on the basis of these three feature you are just predicting whether how much score you will get in the exam. Okay, so this is the three features. On the basis of that you are just saying how much you will get the in the exam. So these three feature will goes to your model, and this will be your prediction by your model. Means this will be your actual, but one model has been predicted, then you will match with that particular law. So this is how I have just represented. Okay, but actually just remember, you will have only one model. It's not like that for every row will the weights will be adjust. No, all the four row it went forward and backward, then the weight will be adjust. Okay, this is how it goes. The four I have just represent this one, because the first row you are just getting this model, the second row you are getting this, the third row is this, and this fourth row this. Only to see, only to visualize you, I'm just making the fourfold of that particular one model, but actually it is only inside the one model it is performing for every row. Okay, the weight are, whenever the weight are adjust, it adjust for all the rows. Okay, so this was the basic concept of the neural network. And here see how this is the prediction. This is actual for the one row, then the second row, the third row, and the fourth row. Then after summation of all, then after you will update that particular weight during the backward propagation. So basic idea about the new this particular is, during the forward, in the brief, during the forward propagation you are just getting some output. Okay, so output, after applying the activation function you are just getting some output, then after you are just matching with that particular actual value. Okay, then after you are just difference of that particular actual and the prediction by the model, that will be your loss. But to minimize the loss you have to do something. To minimize the loss you have to update the weight. To how to update the weight, that comes the gradient descent. With the help of gradient descent you will able to update the weight. So this is the, in the brief I am just saying how neural network works. Again we will go through a depth about gradient descent, and there are a variety of important topic in this particular neural network. Okay, in the deep learning. So that's all for the this video, and hope so if you like this video please subscribe our channel. That's it. Thank you for this.